Bismillahirrahmanirrahim. This video is from Supermesh and it's probably an assignment question sent by a student. And so let's see what is the question. Question says that use mesh analysis to obtain the current IoT. Now this current is IoT for the circuit shown below, given Vs, the source voltage is given, and there is a current source here also. This current source is also given. We need to find I0t. In an effort to try to find the answer from the net, what I found out was that actually this question is uploaded on the YouTube by Gureza Ismail, but she has only done the time domain to frequency domain conversion of the circuit, whereas the question says to find IoT. So we'll try to find that. And maybe there is calculation error. So let me know if you can find a calculation error. Let's proceed. First of all, we have to convert the sine signal. Now this is sine. You know, for converting into phasor, we have to change from sine to cosine. And from sine to cosine changing, we subtract minus 90. So this will be our signal in cosine form. And in phasor, now we can write the magnitude and the phase angle. So this will be phasor form, magnitude and phase angle. And similarly, the current source 5 cos 2t can be written as 5 cos 2t plus angle 0. And in phasor, this will be magnitude 5 angle 0. Now the inductor and capacitor has also to be transformed in the phasor domain. From the given question, we can see that omega is 2, sine omega t or cos omega t. So omega is 2, so we'll use that. And inductor is 5 Henry, so j omega L, j2 into 5, so it will be j10. And similarly, capacitor is 2.5 F, 1 over j omega c or 1 over j to 5 can be written as minus j over 5. And it is actually equal to j 0.25. I think there is an error. So now we'll plug in. Now this value was minus j.02. So we'll plug in all the phasors in this circuit here. So the voltage and the current and the inductance and the capacitance all in phasor. And now you can see this part has a source, current source in between the two mesh. So this can be easily solved by considering this to be the super mesh circuit. And for the super mesh, what we do is we remove the source. We are removing the source from here. So this will be one loop, but the currents will remain same. One thing I forgot, I have marked the currents as I1, I2, and I3. So this will remain there, and the branch that we have removed, we'll treat it separately. So you can see this 5 is coming in, I2 is coming down from here, and I3. So these two circuits, these two figures we'll solve. So first of all, we'll solve the left loop, or the loop 1 I'm calling it, and I hope you can easily follow. We are writing the KVL equation. So minus 1045, then 2I1, and then from here you can see I1 is coming down and I2 is going up. That will be I1 minus I3 into J10. Simplifying, we get equation 3. And similarly, for loop 2 now, we are starting from here. Since we are in this loop, therefore I3 will be have priority. So we'll write I3 minus I1, I3 minus I1 J10, and then minus J2, J.2 I3, and then 4 into I3. Simplifying, this is our second equation, or equation number 4. And then from this, the separated part, we'll have another equation. So current entering is I2, current entering is 5, and current leaving is I3. So this equation. So now we have these three equations that we need to solve. Now you can use any technique that you feel comfortable with. You can find the, from here, take out the value of I3 and put in this an elimination method, as you know. But two techniques I'll show. And that is the easiest I found is the matrix method. So from here we can write the matrix elements. You can see this is for the first one. Since there is no I2, so we'll write 0, I3 minus J10. And similarly, all others, then the current, and then the output voltage is 10 minus 45 and minus 50. Okay, and keep in mind that we need to find I naught, which is actually equal to I3. So we'll actually find I3. And to find I3, we will use Cramer's rule. The Cramer rule says that for I3, you have to use delta 3 divided by delta. There are many videos. You can just watch them. Okay, so what is delta and what is delta 3? Now this part is delta, and delta 3 we replace the third column by the output. We have replaced the third column by the output, so this is delta 3. And now we can solve, or we can write the equations from here. We take 2J10 and then we cross multiply these two. And similarly, this is 0, so we ignore that, then minus J10 and cross multiply these two. And simplifying, you get this answer. Now I'll tell you a technique for doing this easily. I have again many videos. So let me show you. You use your calculator, you go to the complex mode, mode 2, complex mode, and then you just enter all these values. So let me just show you. Bracket 2 plus J10 will be 10I. So we'll just, this is I. So 10I, bracket close, and the next bracket minus 4 minus 9.8 J, so 9.8 I. This is closed. Then the other part plus bracket minus 10 I, bracket close, bracket minus 10 I, bracket close, equal to, now this is the value. We can, it's in fraction, we'll press SD to get the right value. So it's minus 10, 59.6 I. So this is minus 10, 59.6 I or J. And similarly, the delta 3 part can be solved. You will get this answer. And so we have delta and delta 3. I3, we know this is the formula. Plugging in the values, again going into complex mode, can directly solve this to find this value, and from there you can go into the complex mode to find the value in polar form. Let me show you this again. So clearing this, this is the division part. So minus 80, minus 80.7, minus 68.7 I. The numerator is done. We go to the denominator, so minus 10. then minus 59.6 I. So all the entries check correct, and then we go ahead, equal sign. So we find 1.34 and minus 1.12, but we need to find the answer in polar form. So for that, we'll go to shift and complex. This is 2, so complex. And there are options. We select this option R theta 3, and the value is 1.75, and the angle is minus 40. So this is our answer. So I3 we found, and I3 and I0 is same, so this same value. And we can now find the answer in time domain. So this is the magnitude cosine of 2t minus this angle. So this will be the answer in time domain. Now this math, so I hope you've been able to follow this. Please let me know through your comments. Thank you.